Parallelogram is basically a slanted rectangle. And to name the parallelogram, you do not go from left to right and left to right. You have to go in a circular motion. Whichever direction, doesn't matter. So in this case, we'll go from A to B, B to C, C to D. Has to be in a circular motion. Because if you go from left to right, and I do not give you the image, you'll mess up on the final answer at all times. Okay? So let's go ahead and notate everything I know. Parallelogram has opposite sides that are congruent. And the opposite sides are also parallel to each other. And then I want to notate something about the angle. Angle A is congruent to which other angle that it looks like? C?
C.
Then that tells me angle B is congruent to what? Angle D. Now let's make another parallelogram to the right, because if I over-notate in the existing one, it's going to get quite confusing. Let's go ahead and connect the diagonals. Clearly, one diagonal is longer than the other, right?
Mm-hmm.
But they do bisect each other. So let's write everything we know about the figure that we just drew.
Sorry, I have one question.
No, hold, I'm recording. Will you ask me after?
Yeah.
Okay. So if a quadrilateral is a parallelogram, then we know the opposite sides are what to each other? Opposite sides are? Congruent and? Good, and parallel. And then we also know that the opposite angles are what to each other? Congruent, very good. And something that we really haven't mentioned on this unit, but back in unit 3 or 4, we know same side interior. Angles, meaning the angles that are right next to each other. Angle C and angle D are not congruent, but they are what to each other? Supplement. And the diagonals bisect each other. Okay, something unique about this unit, if I ever give you a quadrilateral as a notation, as a picture, that is always representing parallelogram. So if you get a little bit lazy and you want to say the word parallelogram, but instead draw this image, I'll take it. Okay? So let's see if the order is correct. It's saying from J to K, K to L, and L to M. Are we going in a circular motion?
Yes. Yeah.
Yes, we are. Could I also go counterclockwise if I wanted? Definitely, as long as you're going in circles. So what does this notation mean again? It is a parallelogram. So if I know XY is 13, what do I know about WZ? It is also 13, very good. If I know ZY is 4, what is WX? 4. So far so good?
Yes.
Then we have angle XWZ. XWZ. If this angle is 60, what can I say about angle YZW, this angle right here? Has to be 120 because what? They must be supplement. Now let's say we have WXY. This right here, WXY is 120. Then what is WZY? Also 120. So if they're identical, it's got to be the same. If they're not identical, it must be supplement. Good? All right, moving on to the next one. Let's write, the fill in the blank basically comes from the properties, but we're looking at it as a sentence. So, if both pairs of the opposite angles of a quadricongruent, then we have a parallelogram. Now we have if both pairs of opposite sides of a quadricongruent, then again we have a parallelogram. Okay, what can we say about the next one? If an angle of a quad is supplement, to both consecutive angles. Both consecutive angles. Then again, we have a parallelogram. That's consecutive. And then if the diagonals bisect each other, then again we have a parallelogram. And my main emphasis today is going to be bullet point number 5. If one pair of the opposite sides are congruent in, or parallel and congruent, then we have a parallelogram. That we're going to practice using proof today on the back page. And it's not going to be long. So for number 2, what does this symbolic notation mean again? We have a parallelogram. So let's see. We know the opposite sides are what to each other? Oh, parallel and congruent. So let's set them equal. That's a 10, by the way. So if I do solve for x, we get -6, 2x, then I get 14. How many is my x? 7. And it says to find the measure of yz. So here's yz. So 8 times 7 minus 4. 52. Boom. Now we have to find angle z. These two angles are not equivalent, but they are what to each other? Supplement. So we have 18y minus 11 plus 9y plus 2 is equal to 180. Okay, let's solve for y. It's got to be a clean number on this one as well. How many? 7. And that's coincidence. They're not always the same. So it says to find angle z. So when I plug in 9 times 7 plus 2, how many does that give us? 65. Very good. And we're looking at the angle, so degree. Okay, so far so good? All right. On the next page, let's try example 3 with a partner. Go. Talk to your neighbor, please. Make sure you set your calculator on. There you go.
Oh, okay, the diagonals are correct. So 2b equals 4 given 8.
Oh, so we know that these two are those two.
4b minus 8 equals 2b. 8 equals 2b. B equals 4. So 4b minus 4b. So DE equals 8. Wait, I can
So it's 4 minus 8. So 16, 8. In X. Yeah, I know, I might have started.
Mark, what'd you get for V? V? Letter V? 4. So did you also find DE? Mm-hmm. Good job. The other one? Okay, I got it.
Are we doing 7.3 today?
Mm-hmm. How many was my x, Colton?
2.
Yay. How many was AC then?
24.
24. Boom. We're on it. Okay, last question. Let's go over the first proof. On the first proof, I did tell you guys we're going to practice using this. I'm going to abbreviate this big time. All right? So the way I'm going to write this on the very end is going to be if one pair of opposite sides are congruent and parallel, then the quad is a parallelogram. I'm using that notation. If one pair of opposite sides are congruent and parallel, then the quad must be a parallelogram. Okay, how many givens are there? 2. So we know AB is congruent to CD. And let's also notate AB is congruent to CD by the given. Are those two also congruent by the given? Is that yay? Yep, given. So now we can say the quadrilateral ABCD is a parallelogram. Because I know we have one pair that is congruent and parallel.